Okay, guys, so this week and moving forward, we're going to be doing block days. So you guys will get this lesson on the same day that I would have met you for block day when we were still in school. Okay, so this one might be a little tad longer than our others. But remember, one of these days you won't have to worry about a lesson. So let's go ahead and jump into this. Remember, we're dealing with rational expressions, which are when we have a fraction and there's a polynomial in the numerator and the denominator. Right? And we learned about simplifying and also multiplying and dividing. Now we're going to check out adding and subtracting, which are actually a little bit more complicated than multiplying and dividing. Okay, so the steps we're going to take are as follows. First, we're going to rewrite the problem using a common denominator. Sometimes that won't be necessary if we already have common denominators. Okay? Then we're going to combine the numerators and keep the common denominator. Okay? So when we do that, we're going to take two or more fractions and combine them into a single fraction. And then to finish off, we're going to simplify just like we've been doing in the past. Okay, so let's take a look at these examples that have like bases. So these guys are going to already have common bases. Okay, so we're going to be able to have a common denominator and just combine them. So what we'll do here is, for number 1, we have 13a over 4a squared plus 5a over 4a squared. See how they have the common denominator? That gives us the ability to just do 13a plus 5a over 4a squared. We know that 13a plus 5a is actually just 18a. They're like terms, right? And then to simplify this down, we have a monomial on top and bottom. We just look for the biggest number that goes into 18 and 4. Right? That's going to be 2, right? So that's going to be 9 over 2. And then as well as a over a squared is just going to give us an a in our denominator. So we have 9 over 2a as our answer there. So for number 2, once again, we have a common denominator already, so we can combine this into a single fraction, and we're just going to subtract these guys. Be careful with subtraction, because essentially what we're going to do is we're going to do 9x plus 12 minus 7x plus 2. And remember, in a scenario like this, you actually have to distribute that negative. So you'll get hopefully to a point where you don't have to worry about writing out all this work. But what I did is I took that negative and I distributed it, and now I would just combine like terms and get 9x minus 7x is 2x, and then 12 minus 2 is going to be 10. And then to finish off, I'm going to go ahead and do 2x plus 10 has a GCF of 2. So I pulled that GCF out, and 2 over 16 becomes 1 over 8, and I get my answer. Okay, so for number 3, you'll notice we have a common denominator already, so we can just go ahead and add everything and put it under, put it over y squared minus 9. So I'm going to do y squared, 8y and 2y is 10y, and then I got plus 21. But in scenarios like this, you got to make sure that you factor everything you can. So y squared plus 10y plus 21, that's going to be a trinomial that I can factor. I got y, and I'm thinking what two numbers multiply to 21 and combine to give me 10. That's positive 7 and positive 3. And down below, I have a difference of squares. Y squared minus 9 factors down to y plus 3 times y minus 3. I can cancel my common binomials, and I'm just left with y plus 7 over y minus 3. Okay. So let's have you guys go ahead and try number 4 on your own. So pause it and then check back when you're done, and I'll explain it. So this guy already has a common denominator, so I'm going to do 1 minus 16a squared over 12a minus 3. Then I'm going to go ahead and factor these guys. In the numerator, I actually have a difference of 2 squares, right? 1's a perfect square, 16a squared is a perfect square, so I'm going to do 1 minus 4a and 1 plus 4a is how I can break that guy up. Down below, I can pull out a GCF of 3, and I'm left with 4a minus 1. Right? Be careful here, because when you have 1 minus 4a and 4a minus 1, you can break them down, but this is one of those scenarios, because they're in the opposite order, they actually simplify down to negative 1. So you got to throw a negative out in front there. And then if I run this negative through, I get negative 1 minus 4a over 3. Right. So for number 5, you'll notice we got a lot going on, but luckily we have a common denominator, so we can just go ahead and combine it into a single fraction like this. Remember, because we're subtracting, you always got to be real careful with subtraction, because you got to distribute that negative to the n and the positive 1. So when I combine my terms, I got n squared, but then it's going to be 3n minus n is 2n, and negative 7 minus 1 is negative 8. Then I'm going to factor these guys. This guy's going to be n plus 4 times n minus 2. On the bottom, we're going to have something like n plus 3 times n minus 2. The n minus 2 cancels, and we have n plus 4 over n plus 3 as our answer. All right, so we're going to go ahead and just keep moving. So now let's look at some situations where we do not have a common denominator. Okay, so in situations like this, we have to decide what our least common denominator is. And all that is, it's the smallest or the least value, the smallest value that both our denominators can meet at. For example, I have 2x and 3x. And so both these guys, by multiplying specific numbers to them, I could get them both to be 6x pretty easily, right? And then they would be common denominators. All I would have to do is multiply this side by 2. Thing is, I can't just multiply the denominator by 2. I have to multiply the top and bottom by 2. Okay? Over here, I can multiply by 3 over 3. And check it out. I get 45 over 6x minus 32 over 6x. And you see how now we have that common denominator? And once we have that, we can just go ahead and do some subtraction here. 45 minus 32 is 13. We keep our denominator of 6x, and we got our answer. So sometimes we'll have to add in variables as well. So if you check out number 8, we have 4a over a squared minus 7 over 8a. So it looks like the smallest thing we could get our denominators to meet at is 8a squared. To do that, I'm going to have to multiply this fraction by a over a, and this fraction over here by 8 over 8. So that's going to be 32a over 8a squared minus 7a over 8a squared. And you see how when I did those multiplications, I ended up getting the common denominator. And then 32a minus 7a is going to give me what, 25a, right? And then I have 8a squared here. Now, this one looks like we can simplify down the a over a squared, right? And that'll just cancel that a and cancel one of the a's down there. So I'm going to have 25 over 8a is my answer. Right, so let's keep it going, look at some where there's a little bit more complexity. Right? So, if you notice your denominator is a binomial or a trinomial, it's smart to factor things down first. Right? So, for example, here we have k squared plus 16 over 5k minus 10 minus 4 over k minus 2. So, I got k squared plus 16, and I'm going to factor out a 5 right, from the bottom there. And what you'll notice is these guys actually are way closer to each other than we originally might have thought. This is 5 times k minus 2. This is k minus 2. So all we would need to do to get a common denominator is multiply this side by 5 over 5. So that's going to give us k squared plus 16 over 5 times k minus 2 minus 20 over 5 times k minus 2. And you see how now we have that common denominator? So we can just go ahead and subtract that 20. So I got k squared minus 16 minus 20 is going to be minus 4, right? And then down here I got 5 times k minus 2. And now that we've combined it using our common denominator, we got to make sure we factor. K squared minus 4 is one of our difference of squares. So I'm going to do k plus 2 times k minus 2. K squared is a perfect square, 4 is a perfect square. And you'll notice that I can cancel out k minus 2 and k minus 2. And it looks like my answer is going to be k plus 2 over 5. Okay, sometimes we're even going to have to multiply the top and bottom of a fraction by a binomial. So check out number 10. Right? Like I said, for number 9, we got to make sure that we go ahead and factor our denominators to make it a little bit easier. So I'm going to factor this guy, and it factors down to something like this: y plus 8 and y plus 3. Right? And just like in the previous one, it makes us notice that these two denominators actually aren't that far off from each other. Here's y plus 8, this guy's y plus 8 times y plus 3. So all this side needs is for us to multiply y plus 3 over y plus 3 to it. Right? And then I'm going to take this 7 and I'm going to distribute it to each of those. So that's going to be 7y plus 21 over y plus 3 times y plus 8. And then on this side, I didn't change anything, so it's just going to look like that. And as you can now see, we have a common denominator. They both have y plus 3 times y plus 8. So we can just add these guys up. I'm going to have 7y plus, that's going to be what, 56? Over y plus 3 times y plus 8. Then I'm going to go ahead and factor out a GCF up top. 7 goes into both 7y and 56. And you'll notice we can go ahead and we can cancel out the y plus 8s. So we got 7 over y plus 3 as our answer there. Right. So go ahead and try number 11 on your own. Right. And so that means pause the video and then unpause it and you can check your work, and I'm going to run through it. So first I'm going to go ahead and factor this trinomial down here. It's going to be x plus 3 and x plus 2. Right? And now all I need here on the right hand side, I just need an x plus 3. So I'm going to multiply that to the top and bottom of that fraction. Right? So I now have x squared minus 5. And I got, this is going to be x plus 3 over x plus 2 times x plus 3. So I got that common denominator, right? So I can combine them. So I got x squared, and then I'm going to have plus x and minus 2, because I did plus the x plus 3. Negative 5 plus 3 gave me that negative 2. And then to finish off, we got to make sure that we factor this guy. That's going to be x, it'll be x plus 2 times x minus 1, right? Because those two numbers multiply to negative 2, combine to positive 1. And that gives us the ability to cancel out the x plus 2's. And there's our answer for that guy right there. Right? So sometimes we're going to have to go ahead and multiply a binomial to both of our fractions. Like if you check out number 13 here, we have w plus 1 and w minus 7 as our denominators. So we obviously can't factor those. So what we would actually have to do is multiply this side by w plus 1 over w plus 1, and then this side would need w minus 7. So we're going to do w minus 7 over w minus 7. Make sure that you distribute these guys. So it's going to be 5w minus 35 over w minus 7 times w plus 1, plus this guy I got to distribute as well. It's going to be 8w plus 8 over w minus 7 times w plus 1. So the whole reason we did that is because now you'll see we have a common denominator, so we can just combine these into a single fraction. 5w plus 8w, that's 13w. Negative 35 plus 8 is going to give me something like negative 27. And it doesn't look like we have a GCF there. So what I'm going to do instead is I'm just going to call it and say that that's my answer. I can't go any further. Right. So go ahead and try number 14 on your own, and then we'll do it together in just a sec. Okay, so pause it up and unpause when you're ready. And for this guy, it's tempting to think, oh, I just need to like add a 3 to this right side. But no, this is its own expression. So I'm going to actually have to multiply this side by b plus 3 over b plus 3, and this side by b over b. So that's going to give me b squared over b times b plus 3 minus 4b plus 12. I gave that 4 to both these guys, right? Over b times b plus 3. So now I have a common denominator. You do got to be careful though, we're subtracting, right? So I got to give that negative to both these. So it's going to be b squared minus 4b minus 12. I gave that negative to both those guys. And then I'm able to go ahead and combine them into a single fraction. Right? I have to factor this trinomial. It's going to be something like b minus 6 times b plus 2 over b times b plus 3. And you'll notice there's nothing we can cancel, so that's going to be our answer there. Okay, so that was a lot of information, but hopefully it's enough for you guys to be successfully adding and subtracting rationals. What I want you guys to go ahead and do to practice is I want you just doing the odds from homework 2. So that's the odds all the way up to 17 on homework 2. And I hope you guys have a great day.